Hello everyone, I hope you all are doing good in the light of COVID-19 pandemic. This final year project is presented by roll numbers F16SW04, 60 and 156, under the supervision of Madam Memona Sami, belong to the Mehran University of Engineering and Technology Jamshoro. The project is entitled as Automated Gas Meter Reading System, which is suggested by SSGC. SSGC is the abbreviation of Suai Southern Gas Company, which is Pakistan's leading integrated gas company engaged in the business of transmission and distribution of natural gas. Gas meters are used to measure rate of flow of gas. There are various types of gas meters, but here we are considering meters with barcode as per project requirement. Reading the gas meter is the most important part of the job. A meter reader can usually read around 500 meters a day. The system of reading gas meters is manual system around the world. This diagram demonstrates a flow that a meter reader visit houses, reads the meter, and note the gas units that are consumed by respective house, maintain record manually and generates a bill. The disadvantage is, it's taking a lot time to note each meter reading manually. It can also cause human error. Here is a short animated glimpse of manual system. The system that SSGC used is a handheld device. In November 2002, SSGC introduced computerized meter reading called handheld. This handheld weighs 340 grams with 18 hours battery backup. It can operate in a temperature between 10 to 55 degrees Celsius. This software is developed with C language and works on DOS system. This diagram demonstrates a flow that a meter reader reads multiple meters zone-wise through handheld, and enter record manually into the device and the database by a data entry officer. It has advantage of capacity to store data of about 3,000 customers, but the disadvantages are, it is semi-automated. To cover these drawbacks, we proposed an automated system. The proposed idea meets the solutions associated with the major problems related to the manual gas meter reading process. An Android application is introduced that captures a meter image and extract information using OCR technique. The idea not only give ease to the meter readers and the company but also to the users, as they can check the readings of their own meter, self-billing and many more. There is an admin side as well which controls all the user activities, generates bill and many more. Here is a short animated glimpse of automated system. The advantages of automated system are, reduce human effort and human error. Now moving towards live working of a project. First let's have a look on how the mobile application works. It contains two modules. Meter reader module and the consumer module. In the meter reader module, it is asked to enter a code to read the meter via camera and scan the barcode from the meter, as the barcode contains meter number or meter ID which is unique to every meter. To fetch the consumption units, there is an option either to scan from camera or camera roll. If choosing from camera roll, the digits are cropped. Out of 8 digits it count only 5 digits for the processing. There is an algorithm at the back end. Now meter reader get important data of customer, which is meter it and consumption units with the image of consumption. This information can be saved to database. Handled by the admin side. In the consumer module, there are two options: bill calculation and complaint. In the bill calculation, consumer can calculate the bill by himself. Here are 4 fields. To enter the current reading from meter and previous reading taken by reader. The current reading should be greater than the previous reading, otherwise it will not generate the bill charges. And the third is pressure, which can be modified, but default pressure is 0.25, and the last but not the least is GCV, gross calorific value, which is 1000, but it cannot be less than 800 or greater than 1200. Now if all conditions are true, it will generate the bill charges. After then, consumer can see the bill that has the total units consumed, the meter rent, GST tax which is 17%, the gas charges, and finally the total. Now let's have a look on admin side website that control all user activities. Admin logins with the secure credentials and will navigate to a page having 4 input fields: account ID, name of the consumer, address and city. Account ID is the meter ID which is unique to each consumer meter. Inputting the account ID will show the details of respective consumer meter. The meter is read at what date and time, the read difference, the registered reading, the meter type, and etc. So now let's come to the overview of database. As we already mentioned that we are using Firebase database, which is a cloud-hosted NoSQL database. Here is the main real-time database that which are using, and its format is JSON. And you can see the parent object of database, which is customers. In customer database we have all detected barcode number known as meter number of the particular user. Every user have their own detected reading, which is detected by a meter reader. The consumption reading will increase as the reader reads the meter every month. Working of database is totally dynamic and automated. Here is our storage which we are using for store the images of meter. This is all the data of a particular consumer consumption image which is taken by the reader during the reading of the meter. And you can see the clear images of consumption number which is in JPEG format. This table shows the major similarities and dissimilarities of the related gas meter readers papers. The idea to create this table is to make a clear vision that what innovative things are implemented and what new we have to do. This table is describing the significant work of different relevant applications. These applications are available and currently used by many users. This table helps us to decide who's in our application. Like we decide our objectives based on related applications that our app should have: feature a billing history, register complaint, save bill, billing information, self-billing and self-meter read. The tools used in developing this project are Android Studio, Sublime Text, Google Chrome. The technologies used are Java, HTML, CSS, JavaScript, React.js. The database used is Firebase real-time database. And the APIs used are Google Mobile Vision and Xing Barcode. These are the reference links to this project video. That's all our efforts and hard work. We hope you like our project idea. Thank you.